Good morning, everybody. So thank you for being here for the last seminar of the winter-spring semester of the WEFI seminar series. So today we are very excited to have Lindsey Raymond from MIT, who is gonna present like the market effects of algorithm, and Runshan Fu will discuss. So Lindsey, you have 45 minutes.
Okay, great. Well, thank you very much for having me. I'm excited to close this semester. So I'll be talking about my job market paper, The Market Effects of Algorithms. So as many people are probably aware, we're seeing increasingly algorithms or some sort of automated software model to make decisions in a variety of settings in the real world. So for instance, we see them evaluating people. So when a judge is deciding, should I bail to this person, there's sometimes a risk model in the background that's giving an input to the judge. When you go to a hospital, oftentimes there's some sort of model that will estimate your risk of having a heart attack or some other health condition. Now, we also see them doing things like valuing assets. So when you turn in a used car, now there's often some model in the background that's computing its value. Or when a new song is written, often there will be a model that's estimating, is this likely to be a hit? And then probably most familiarly to the people in the audience, you see models generating suggestions. So as you're typing an email, there's this auto-compose feature you're faced. Now, with this growing use of algorithms in the world, we've seen the academic literature focus on two questions in particular. So the first is asking, when we use an algorithm to say estimate risk of committing a crime, how does that compare to the human judge? And this is a very wide literature, so very interdisciplinary. And really the challenge here is the econometrics. So is the human thinking about a different decision problem than the algorithm? Are there unobservables? Things like that. Now, this next question that has received attention is asking, does the improved predictive capabilities of an algorithm, is that useful? Does that translate into something like firm level productivity or efficiency? And as algorithms are increasingly used, in a variety of settings, we're seeing more and more work asking this question as well. And what we know is, in many cases, algorithms can surpass human experts, and in many cases, that does actually translate to like improved fleet efficiency, say in a trucking context. But notice thus far, we've very much been focusing on within the boundary of a single firm, and we're mostly focused on predictive accuracy. So thus far, we haven't thought about prices. We haven't thought about other firms that might be competing with this firm, or anything that goes beyond the boundary of a single firm. And these are all things that economists think quite a bit about, so it's kind of surprising that we haven't gone beyond that. And I started with this slide where I showed you examples in three categories: evaluating people, evaluating assets, or generating suggestions. But I could also show you these in two groups of examples. There are examples in red where the prediction decision is taking place in a market. So when you're thinking about hiring someone, you're thinking about what's the price, what is the wage, and there might be other people trying to hire that person in the market. Now, in contrast, thinking about someone who may or may not get bail, that's a non-market context. So those examples are in black. And in this paper, I'm going to ask, does use of predictions when it's in a market, does it have other market effects beyond just predictive accuracy? And I'm going to think about three specific examples of market effects. First, when algorithmic prediction becomes available, do we see changes in market structure? Do we see a change in the people who are participating in the market? How do algorithmic and human prediction exist in equilibrium? Do they coexist? Are algorithms pushing out humans? And can we sort of say anything about the pattern of effects? And then lastly, do we see any changes on market prices or market efficiency? And some of the problem level evidence has shown that indeed, when you give people algorithms, they make different decisions. And if markets are just collections of individual decision makers, you might actually see a change in the aggregate market price as well when algorithms are rolled out. Now, one of the reasons that there has been less on these sort of effects is because they're very difficult to empirically study. So we can't really do the experimental design where we have one group of people, we give them access to an algorithm and compare to a group who don't. We're going to need some market level treatment And we're going to probably need some sort of natural experiment because it's very hard to randomize at a market level. And so in this paper, I'm going to focus on the US residential housing market. It's interesting because it's a very important asset market. It's also sort of a surprising setting for algorithms because in the housing market, soft information, lots of non-quantifiable, unobservable information probably plays an important role in what makes a house valuable. In this market, the prediction problem we'll be thinking about is investing. So investors are making a forecasted house value. And then there is going to be this market level source of variation that's going to allow us to get at causal questions around market prices and allocation. And I'm going to talk a lot more about the natural experiment in a couple of slides, but let me give you the flavor of it right now so you get a sense of where we're going. So this graph, the y-axis, shows the share of counties in my sample that have switched to digitized housing market records. And this is across, the time period I'm studying. And so as a result of various, county government processes, I'm going to use this rollout of digitized housing records, which are a key input into building algorithms to value houses. They provide important historical data, and we're going to use that to set up the empirical strategy that I'll tell you about in more detail later. So I'm not going to talk about all of my findings just because of time. So I'm going to give you a flavor of what the paper does and then focus more specifically for the rest of the talk. The first thing I'm going to show you is that digitization of these housing records led to entry of investors who are using algorithms to value houses. It's kind of like the first stage, showing that indeed this is a useful natural experiment for getting at the question we're trying to study. Next, I'm going to look at what happens to humans and algorithmic investors after digitization. So I'm going to introduce a conceptual framework that's going to allow us to think about comparative advantage. So I'm going to set up something where humans have a comparative advantage in valuing houses where the unobservable information that only they can see matters, while algorithms may do better on houses where humans are making systematic prediction mistakes. And then I'm going to empirically look at patterns of investor specialization using that framework. We're going to first see that after digitization, human investment is going to shift. So they're going to become more likely to buy houses where models struggle. And that's both because I'm going to go into exactly why that's the case, but we'll not talk about it in this talk. I'm also going to show you that algorithmic investors are going to disproportionately buy minority-owned houses where humans seem to be undervaluing those houses, and I'll show you evidence on that. And then on the last section, I'm going to look at what happens to prices, particularly prices of minority homes, and then ask, is this because the algorithmic investors are falling prey to adverse selection because they can't see all the information available to the humans? Or is this some real arbitrage opportunity that they've discovered? Broadly, there are two types of contributions. So there's this small but growing literature on market effects of algorithms, often thinking about algorithmic pricing and collusion, use of algorithms to design markets, or market liquidity and efficiency in financial markets. So this is going to add, entry, specialization, and prices to that literature in the housing market. And then, as I'm going to talk through later, this is also going to contribute to this very large interdisciplinary literature thinking about algorithmic bias, how algorithms might inadvertently perpetuate patterns of discrimination. And I'll talk more about that specifically when I get to the prices section. And then lastly, there's actually a lot of public data that's useful in building algorithms that has been digitized as part of this process that I'll talk about later. And so you can imagine taking this empirical design and using it to study algorithms in another setting. So now I'm going to talk to you a little bit more about the housing market. Then I'll get into the data empirical strategy and then go through the 3 sets of results. So the housing market, I'm going to be looking at single family homes, which are just detached residences intended for one household. In this market, there are 2 types of buyers. So there are owner occupiers. If you bought a house to live in, you've been in this category before. This is really a consumption decision. You're buying a house, you're planning to live in it for about 15 years. And individuals buying houses to live in is the bulk of all housing transactions in the US. Now, the remaining part of the market are investors, and these are individuals who are purchasing a house to rent out or resell. They make up 15% of the market, but they're a very important marginal buyer, and these are individuals who are making a prediction. I'm going to look at 4 states, Georgia, North Carolina, South Carolina, and Tennessee. I'll tell you why those 4 states in a couple slides. In these 4 states, single-family homes are most houses, just like the rest of the United States. They're also the largest single segment of the rental market, both in rural and urban areas. A key important part of a house is that each single-family house in the US is highly heterogeneous, so it's not like a commodity market. And it's characterized by non-trivial search and transaction costs. And then lastly, it's an area where government policy has played an important role because access to houses and prices of housing are important for household wealth and intergenerational patterns of that over time. So what is the prediction problem that investors are thinking about? They have 3 things that might matter. So rental income, if they're planning on renting out a house, expenses, both initial repair and ongoing maintenance, and then the future value of a house. So what can I sell it for in the future? Now, investors in this setting, we're going to divide them into 2 categories. So when I say algorithm, what I'm going to be talking about is a supervised learning model that makes predictions based on historical data. In other settings, this might be a different definition, but this is what's appropriate here. We're not saying that these are particularly good models or particularly sophisticated. They're just using this data-driven approach based on historical data to make forecasts of house value. And an algorithmic investor is an investor whose screening and investment decisions are going to be based on this model. I'm going to tell you exactly how I operationalize these definitions in a couple of slides when I get to the data section, but these are like the conceptual analogies. Now, humans in the market are not, throwing darts at a wall. In general, human investors use some sort of heuristic, which here is a buy box. And so when I say human investor, it's an investor whose investment decisions are made using human judgment. So what is a buy box? A buy box is basically like a checklist that each investor constructs that guides which houses they buy or how that process happens. This is the buy box of one of the largest human investors in Tennessee. They look for stable blue-collar neighborhoods. They have a list of neighborhoods they've invested in the past that they try to do so in the future. They look for specific types of low-maintenance construction. Now, this sort of like buy box can vary a lot across investors. So others, like it's much more, I drive around and I look for houses that seem good. And there's obviously a lot of discretion over how they follow this, but this is just to give you a flavor of kind of broadly what human investors in the market are doing. Okay, so now that we've gone through the setting at quite a very high level, I'm going to talk to you about the data and empirical strategy and also exactly how I measure human and algorithm investor. So the first piece of information is this year when each county digitizes their records. That's going to be hand collected from the county governments. When I talk about the empirical strategy, I'll talk about what those records contain and how the digitization process happens. We're going to also use the county data on housing stock and sales, and that's going to allow us to keep track of which houses are sold, who buys them, what they were sold for. In the US, this coverage of this data varies quite a bit across states and counties. So these 4 states are ones where the sort of fraction of the actual housing transactions that are recorded is very high, so it's very good data. This also means probably these 4 states are ones where your ability to use an algorithm based on historical data is probably better than it might be in a state where the data quality is very poor. Something to keep in mind. And then we're going to add to that a bunch of socioeconomic and demographic data from the census, the ACS, and then just aggregates of housing market activity from Redfin and Zillow. So these records, for every county, we know who the price someone paid for a house, and the house, information on the house, and the name buyer and seller. And that's going to allow us to differentiate every individual into either an owner-occupier or an investor. We're going to use the definition of an investor as a corporate entity that purchases houses to rent out or resell. And then from that universe of investors, we have their names, their corporate addresses. We're going to match that to personnel records from LinkedIn, so who they employ, any public filings that they make, websites, public interviews, and business registration data. And then we're going to classify them into an algorithmic investor if they say we are using an automated valuation engine, or like we use an AI-based approach to value houses, or they employ a data science machine learning team. A human investor is one who does not fall into that category. In the data, the largest algorithmic investor is someone called Amherst Residential. In their filings, they have this description of their algorithm that they built, which is a way for them to identify and value desirable properties. Importantly, the algorithmic input is happening at the screening stage. So there's no algorithm that operates without human input. Basically, the way the algorithms work is they screen through available houses, come up with a price, and subset to a list of 10 properties. But a human still has to go write up an offer and give it to a homeowner. The human investors, this is one of the largest human investors in Georgia. Generally, they often have a very high level description of their buy box on their website. This person employs 8 human individuals who clearly have grown up in Georgia, are very embedded in the local community. And that's how he looks at and values houses. Okay, so kind of going back to this ideal experiment, what do we want the empirical strategy to be doing? In an ideal world, we want one market where algorithmic prediction is possible. So basically, any firm in the market, I can build a model and I can value a house. And I want to compare that to a market where just human judgment exists. And then I want to look at, say, how prices in market A differ from prices in market B. Now, this is really important because I want to be able to say that the change in prices was a result of the algorithmic prediction or algorithmic activity, as opposed to the fact that the algorithmic investors were good at entering markets where the price of houses was rising. And so that's the key reason that getting this right matters. Now, the first challenge is, what exactly does it mean to make algorithmic prediction feasible for all firms in a market? There are many investors, they're all building their own version of an algorithm, and that's one of the cool things about studying the market level. So how do we turn on algorithmic prediction for any firm that might want to enter that market? And then, as I mentioned before, whatever this is, we're going to need some market level variation. So I'm going to go back to this graph that I showed you earlier. Kind of the main input into machine learning algorithms is they depend on machine readable training data. So supervised learning looks for historical statistical patterns in data and uses that to make predictions or inferences. So the key input is the historical training data. In the US, in the early 2000s, there was this larger open government movement where the idea was to make government, both federal and local, more open and transparent. So there was an effort to digitize a lot of public records. Digitization basically means going from keeping all records of housing transactions, which is something that counties just do as part of they're supposed to do that by law. Previously, they kind of kept them in paper books, often in their basement. When they digitize, that means they go through, scan all their records, and put them online in a database format that you can access without going in person, reading through the books. And so what I'm going to use here is the county digitization is a drop in the cost of using algorithmic prediction in that county. In the 4 states, this is the state-by-state digitization patterns our sample. In general, there are like basically 3 things that had to happen to make digitization possible. There had to be funding allocated. There had to be basically coordination on, we're all going to abbreviate street this way. We're all going to, use this format for our records, which took a lot of time. And then lastly, they actually had to physically scan all of their historical data and put that online. And so the open government movement kind of started a lot earlier, but it just took, often like 5 years for this process to happen. So this is going to set up our first event study, which is a county level rollout. The first thing I need to show you is that algorithmic investors respond to digitization of these records. So maybe there's some other data source out there that like they can use to value houses, and digitization of these records actually doesn't have any effect. So that's the first thing I need to establish. So the first, we're going to use county and year fixed effects. We're going to use this year of county digitization. And then we're going to first look at the beta J's. We're going to, because there's differential timing, we're going to sort of adjust for that when we calculate this. Okay, so before showing you the event study, I'm going to show you some raw data. The y-axis is the algorithmic investor market share, and that's the number of houses they purchase divided by the total number of houses sold in that county and year. And so what you'll see in the raw data is it's pretty much 0 before digitization, and it hovers around 2% post. And so that's 2% of all transactions. As a share of all investors, that's about 10%, 10 to 15% of the investor market. Okay, now I'm going to show you the event study coefficients for its effect on market share. Kind of just like you see in the raw data, we see a spike, and then it sort of continually hovers around 2% over time. We can estimate this a variety of ways. We broadly get very similar results.
Lindsey, can I ask a quick, we have a question from Neroli. Do you want to ask it? It's a good one.
Right, so the algorithmic...
I was just wondering who the algorithmic investors actually are here, because I had thought that they would be sort of iBuyers who we know relied very heavily on algorithms, whereas it seems like the treatment is mostly going to relate to these buy to rent investors.
Right, so the algorithmic investors, in my the way I define them, are not limited to the iBuyers. So I'm basically looking for any investor that is using an algorithm to buy houses. So most of them are companies like Amherst, which are real estate companies or private equity firms. There are, the iBuyers are in the sample, but they're kind of a very small fraction. So like I would say probably no more than like 15%. So they're in the sample, but the like modal firm is that Amherst Residential, which is, they were, someone who invested in commercial real estate and started this new company to take advantage of, to invest in single family houses, and they use an algorithm. Okay. Okay, so with this sort of county level, one thing we should be fairly, worried about with this county level rollout is, what if there are other things that are driving both digitization and investor interest? There are a couple of other things that we want to be careful about with the empirical strategy. I'm mostly going to talk about violations of the parallel trends because it's something we're going to use later as well, but happy to talk about any of these others offline. Okay, so within each county, there are some, as I sort of alluded to before, it actually takes quite a bit of time to scan all their historical data. So within each county, there are some houses that have been digitized. So if you go to the county's website and you go to their data set, you'll find information on that house, what it was previously sold for, characteristics of the house, things like that. And there are other houses that they sort of haven't yet added, but will over time. And so we're going to take advantage of this within county variation. This is the graph of the like house level version of the first graph I showed you, to ask, to set up a triple difference. And this is going to allow us to say, are there any other county level trends that affect both digitization that could be driving our results? And in general, algorithmic investors buy very few not yet digitized houses. We can do a series of other falsification tests comparing similar houses within like a census block group, so on and so forth. And this is kind of a way to assess, are there other things going on, or are they really reacting to data availability? I'm gonna, just because of time, I'm gonna skip forward, but we're also going to use this house level digitization later to ask some house level questions. Okay, so broadly, we've kind of like set up this difference between the algorithms and the humans, like the Myers house buyers versus Amherst residential. And in terms of what they're trying to do, let's assume there's some underlying house common value Y that depends on observables, which I'm going to represent with X, and unobservables Z. Now, the Z is human private information. So it's the unquantifiable things about a house that might impact value. You know, street noise, is it like a nice interior layout? And this is often the first thing that people talk about when they're comparing humans and algorithms. But if we just focus on the private information, then algorithms are just informationally impaired humans. And it's hard to imagine, like that doesn't give any room for algorithms to outperform people, which is what we kind of seen with some of the problem level evidence. So I'm going to introduce a second component, which is the fact that humans often make errors in prediction decisions. And you can sort of microfound this in a variety of ways, depending, you know, pick your favorite behavioral bias. I'm going to talk about one specific type of human bias, which is racial bias later. But this is kind of just to motivate the idea broadly. And without private information, humans are just cognitively impaired algorithms. So this is like, that doesn't totally feel right either. So this is really going to set us to think about a trade-off. So a human investor is forming a conditional expectation of house value both on X and Z, but maybe they're going to make some prediction errors. Now, algorithms, they have access to X, but not Z, but they're not making this like potentially taste-based bias decision. So when we look at the difference between a human prediction, H, and the machine prediction, the difference could be due to the human informational advantage, or the fact that the humans are making mistakes. And so this kind of gives two predictions. Humans should specialize in houses where that informational advantage matters, because that's something they can do better than algorithms. If there are houses where humans are making systematic mistakes, that's where algorithms should specialize. And we have to be very careful at looking at any disagreement between a human and algorithm, because we don't know if it's human error or just these unobservables that might matter. So I'm going to first kind of investigate whether or not human investment shifts in ways that suggest they're moving toward houses where unobservables matter. I'm not going to talk about that, but there are basically two approaches. One is use some institutional details that vary across houses, and one is to try to like come up with a measure of ex-ante house predictability. Now, for the algorithm comparative advantage, it's kind of hard to imagine that there are systematic opportunities in the housing market where like humans are making mistakes. It turns out there are actually a lot of examples of this. I'm going to focus on race, which is one of the most well-studied of these. And there's something in our sample, which has been pointed out by other people. There's a 5% unobserved or unexplained difference between the price a similar house sold by a white homeowner sells for versus a minority homeowner. I'll tell you more about how I calculate that. That's kind of an indication that there may be something here going on that we will investigate. To go down, I'm going to now go down to this house level regression framework, hedonic regression framework, where the outcome is now whether or not the house was purchased by an algorithmic investor, so 1 or 0. I'm going to use the house level digitization, so when the house record was digitized, and I'm going to compute that effect separately for white-owned houses, versus minority-owned houses. I don't know why that disappeared. And the way I'm going to get race is I'm going to infer it from name using Bayesian improved surname geocoding. This is kind of widely used in fair lending analysis. It seems to be reasonably accurate, but of course it's not perfect. So whenever I say race, you should think inferred race. Now, what I'm showing you here is kind of the coefficient of the impact of house digitization on likelihood of being purchased by an algorithmic investor, separately for white houses in blue versus minority houses in red. And what you're seeing here is that digitization has a 2x effect on a minority-owned house. I'm going to do the same analysis. I'm just going to compare within a smaller geographic. I'm going to compare observably similar houses within a smaller geographic area, now within the block group, and it's still about twice as large. Now, comparing within the census block, it's actually 6 times as large. So basically what this is telling us is when a house is digitized, the likelihood of being purchased by an algorithmic investor is 2 to 6 times as large for a minority-owned house, which is like a surprising difference, quite large difference. And so when we look across all houses, basically the algorithmic investors are disproportionately likely to buy minority houses, even within when you're comparing houses within the same small geographic area. And their portfolio is like double the share of minorities as the average human investor. So basically, we're seeing this like very different patterns of where they buy houses. We're going to sort of next try to understand why that might be the case. So now I'm going to tell you how explicitly how we calculate this race penalty, and this is something that doesn't have anything to do with like digitization. We're just on the left-hand side taking sales price. We're including a indicator for whether the house was minority owned using inferred race, and we're controlling for all observable characteristics of the house. And we're comparing within the same census block group and transaction year. And this beta M is like the race penalty. It's the unexplained residual difference in sales price comparing houses within the same neighborhood. It's important to say this is not necessarily a causal interpretation. There could be things that we're not including in the regression that matter. And there have been many possible mechanisms that have been proposed in the literature for trying to explain this. In our sample, it's about 5%.
So there is a question, Lindsey, for you.
Mm-hmm.
So is the digitalization related to the timing of the last sale?
So is the digitization related to the timing of the last sale? So yeah. It doesn't appear that to be the case. If you do balance tests based on time when the house was last sold, that doesn't appear to be like correlations between the two. And also sort of based on our conversations, some conversations with county officials, it didn't seem like there was a systematic pattern in how they digitized. It's a good question. Sorry, with the caveat that being, if a house was like newly constructed, it would obviously be digitized later if it didn't exist earlier. Yeah. Okay, so in the pre-period, we have this 5%, difference in the house, and this is a within neighborhood difference. There are also cross-neighborhood versions of the race penalty. That's not what we're studying here. In the post-digitization period, among houses purchased by algorithmic investors, there is no race penalty. And this blue bar is a little bit artificially widened, just so you guys can see it. But in general, once you account for all observable features of the house, algorithmic investors pay the same price for the same house within the same neighborhood. And now it's sort of clear that now why algorithmic investors are sort of ending up with so many minority houses, right? Because if everyone else is on average paying this lower price for minority houses, but they're not, then they're probably disproportionately likely to win those. Now, the first thing that kind of comes to mind when we think about this figure is like, is this some sort of adverse selection, or is something else going on? And so we're going to sort of decompose this difference a little bit more to try to understand that. Now, so on the left, I'm showing you algorithmic investor purchases. This is the race penalty. On the right, I'm showing you human investor purchases. So these are purchases by human investors in dark blue in the pre-period. And so it's like on average 7%, so a little bit larger than the average race penalty in the pre-period. But it also falls in the post period to about 1.7%. So basically in the post period, the prices that human investors are paying for minority houses is rising. The sort of like unexplained residual difference is among houses they end up purchasing is going down. We can also add in owner-occupiers. So owner-occupiers are, the individuals just buying houses to live in. They're most of the market. In the pre-period, their race penalty is about 5%. It also falls to 3% in the post-period. And this is really interesting, and I think illustrates one really important market effect. So algorithmic investors, they are trying to buy houses. So they're out competing with other people in the market. And as a result, because of this competition effect, the price, even if they don't win the minority house, the price someone else might pay for the house is now higher than it was in a world where there were no algorithmic investors. And this is kind of like one important channel of an indirect effect, where when you start thinking about the market, or when you think about a market setting, that might matter, and thinking through aggregate effects. And in fact, if you sort of do a decomposition of the total change in price, most of the change in the price of minority homes after digitization is due to the fact that owner-occupiers are now paying more because they're just such a large part of the market. The second channel that matters in this market, and I'm not able to sort of decompose what shares due to each of the two channels, is the fact that there's a really important intermediary in this market, who are real estate agents. And so they're sort of helping set the prices, the initial listing prices of houses. And so when algorithmic investors enter the market, they may be adjusting the prices that they're listing houses for kind of in response to this new player in the market. And if we had just been thinking about, the algorithms in isolation, we wouldn't necessarily pick up this kind of important indirect effect. And I think highlights why in a market, trying to think about how entry of algorithmic prediction might affect others in the market, it matters. Now, I said I would come back to this algorithmic bias point. So if you look at the difference that in price an algorithmic investor pays for a minority owned house versus a white owned house after you account for observables, there's no difference. So you would probably, if you were a regulator analyzing that algorithm, you'd be like, oh, it's a race neutral algorithm. But because it comes into a market where there's this pre-existing racial disparity, and as a result, we see it going down, it's having a positive effect on this disparity in the market. And kind of, again, not something we would pick up just by studying the algorithm or the firms themselves. And so here, basically, the idea that we're having some positive effects on algorithmic bias, but it's happening mostly through this competition and price updating mechanism effect, as opposed to the algorithms themselves. Okay.
You have 2 minutes left.
Yeah. So on average, it falls. Now, kind of an important question is this happening because is this the digitization or is this the algorithms? So I'm in dark purple, I'm plotting to you the racial bias or the race penalty on average pre-digitization. In kind of medium purple, I'm plotting it for counties where there's digitization but no algorithmic entry. All counties digitized, but algorithmic investors only enter a third. It's fairly similar to the pre-period. And then in counties where there is algorithmic entry, which suggests that really it is due to the entry of algorithmic investors rather than this just broad change in the digitization. Okay, so the last thing that I'm just going to call out that I look at is, are these homes that algorithmic investors buying, are they paying too much for them because they're unobservably bad? And to understand that, we can look at whether or not the resale margin, the difference between what they buy the minority house for versus what they sell, is different across minority versus white homes. And then we can also calculate margin by looking at assessor estimates of market value, just like a complementary way to calculate margin that gets at a larger swath of houses rather than just those that are just resold. On average, we don't really see any systematic differences in margin between the houses the algorithmic investors purchase from minorities versus white. Can do that more systematically. And that kind of suggests that that's not consistent with the fact that this is just pure adverse selection. Okay, so now to conclude, data and algorithms, I think, can reshape markets. So we've seen that digitization of these public records led to entry by this new class of investors, not something that, you know, the county officials, when they were trying to come up with these sort of processes, would have predicted, but something that they're now having to think carefully about in terms of like, how accessible do I want to make my records? Like, do I want to make it really easy for someone to come in and scrape? Or maybe do I want to have some more prevention measures to ensure that like they're not being used in this way? That I think is a new question these kind of officials might need to face. We saw both changing human and algorithm investment patterns, and we saw impacts on price. And I think sort of this illustrates why in settings where you're thinking about prediction in a market, kind of thinking about the competition effects, thinking about the price effects matters for fully capturing the impact. I think more can be done when thinking about from the firm's perspective. Like, do you want to design your algorithm to think about maybe the fact that I might change price and that might affect what my optimal strategy is? And then also for policymakers who have been paying a lot of attention to how these investors have been impacting prices. The investors say we are by a too small fraction of houses, so we can't possibly be impacting houses. But I think my analysis here, because they have this like large indirect effect, kind of suggests otherwise. So thank you very much for your attention, and I'll conclude there.
Thank you very much for this excellent talk. So Runshan, do you want to share your slides? So we'll keep some time at the end for questions. So keep your questions, and Lindsey will answer them at the end. Okay, so whenever you're ready, Runshan, you can go.
Okay, can you see my slides? Okay, wonderful. Okay, thanks, Lindsey, for a wonderful presentation, and thanks for all the lovely organizers of this workshop to invite me to do this discussion. This is actually my first finance workshop or conference ever, so I hope whatever I'm going to say next is going to make sense to this audience. Okay, so I think Lindsey did a great job explaining the paper very clearly, but I just want to quickly offer my take of the paper, basically summarize the paper using one slide. So basically the research question is very clear: how the availability of algorithmic predictions changes entry, allocation, prices in US residential real estate market. And the key identification strategy here is the digitization of housing records. As Lindsey explained, it's kind of difficult to have an ideal world where in the treatment group we have algorithms and in the control group we don't have the algorithm. So she leverages the digitization of housing record, which is a key driver of the use of machine learning algorithms. And there are a couple of interesting findings, and basically all those findings are comparing before and after digitization. So the paper shows that after digitization, first there's an increase in the properties brought by algorithmic investors. And actually it's more clear in the presentation. Basically pre-digitization, there were very few algorithmic investors, which again shows that digitization is a key driver. Those like machine readable data is essential elements for use those machine learning algorithms in the housing market. And second, there's an increase in firm size and the number of invested geographic areas. So this kind of answer my question after reading the first result, which is there an increase in the number of investors, or is there basically an increase in the size of the company or the expansion of those firms? So it says that it's actually increased the firm sizes and also increased the number of invested geographic areas, because now with algorithms, those investors could scale the transaction, scale the purchase process, and target more geographic areas. And then the paper shows that there's a shift in market structure. After digitization, we have increased number of algorithmic investors, but those human investors still stay in the market. They are not driven out of the market. They just shift into a different portion of properties. And in the paper, there's a very nice theory about how the market structure is going to change. Basically, algorithms and human investors are going to focus on what they have comparative advantages. So for algorithms, they're going to target areas or properties where human errors are most prevalent. And for human investors, their advantage is more information about local market. So they're going to target houses where private information is important. And the paper shows a number of empirical results that are consistent with the model predictions. Another part of the paper is focused on this racial penalty, which is a result from one specific type of human bias. So after digitization, algorithmic investors disproportionately buy minority-owned homes, and it's not just minority concentrated neighborhoods. They actually like focus on minority-owned homes, and they do not show any racial penalty in terms of the prices of the transactions. And very interestingly, in addition to the like non-existence of racial penalty within algorithmic investors, we also see that risk penalty reduced among human investors and owner occupiers after digitization, which suggests that through some like maybe competition or other market mechanisms, the reduced racial penalty basically spill over from algorithmic investors and also to a broader portion of the market, namely human investors and owner occupiers. So that's my take of the paper. There are many other interesting results in the paper, but these are what I got most from the paper. So overall, I think this is a really nice paper. There are many things to like about the paper. So first, it studies a very ambitious and important question, and it provides a very unique perspective. So there are many papers studying the algorithms or the impact of algorithms on decisions, and most of the papers focus on individual decisions. And the perspective provided by this paper is that those individual decisions could have further downstream impacts, and they could those decisions are going to interact with each other. They are going to influence the entire market. So depending on the situation, depending on the context, those individual decisions are going to have market level impacts. And I believe this is just a very nice, very unique perspective. And it actually points out a direction where like researchers who are interested in the impact of algorithms should also look into. So not just about the impact of algorithms on individual decisions, but also on market level impacts. I also want to highlight the interesting data collection and the compilation in this paper. I think Lindsey went very brave on those points, but I was very impressed by how she collected all kinds of data from various sources and from the data to identify different variables needed for this analysis. And this includes interviews to get details about digitization, how to identify investors from the names of buyers and sellers, identify homeowner races using deep learning algorithms, and also like to measure house predictability. And I understand that housing data is very messy, so it's very impressive that she put together all those data to answer the question in this paper. And the result analysis is very solid and also very creative. It utilizes the variation in digitization timing, and the paper also provides a number of balance check, discontinuity analysis, falsification tests. So I think this is a very solid analysis. And there are many times when I read the paper, I got a question, and basically the next paragraph in the paper is about answering my question. So I just think this is a very interesting read, and this is a very solid analysis. And last but not least, the paper provides a very rich and compelling story. It focuses on the dynamics between algorithmic investors and human investors, and it also tells something that have far-reaching impacts on racial disparity. So I think the overall story is also very well organized and very compelling. So there are many things to like about this paper. And I guess as a discussion, I have to say something about the suggestions and comments about this paper. I guess most of my questions and suggestions are about like clarification or positioning or just basically going deeper into the mechanism. And I think some of them has already been answered by Lindsey's talk, or at least partially answered by Lindsey's talk. But briefly speaking, I have 3 comments. The first is about like a positioning question. Is this about the impact of algorithms, or is it about the impact of digitization? So the question is about the impact of algorithms, which I think is a very important question. And the analysis mostly focus on digitization. So most of the results we see in the analysis are about what happened after digitization. And I understand that digitization is a key driver of algorithm usage. And I think this is a very clever way of getting somewhat exogenous variation in algorithm availability. So I think this is very clear, and it is very clever. My concern is that digitization also affects other things in the market. One, it also powers consumer-facing algorithms like Zestimate. Zestimate is an home value estimate powered by machine learning algorithm provided by Zillow. It is available for most of the properties in the United States, and people, like consumers, anyone can just go to Zillow and look at this specific estimate for a specific property. And similarly, we have Redfin Estimate, and we have a number of other consumer-facing algorithms. So those algorithms, well, theoretically, they could also be used by investors, but they can also be used by just regular buyers, sellers, home occupiers, or even human investors. Well, so this is one part. Well, you can argue that these are still machine learning algorithms, so this could still be broadly categorized under the availability of the algorithms. But then we also have, with digitization, there are more available information in the market. For example, now with Zillow and other online real estate websites, I guess related to digitization, they also show more like listings or more property characteristics online. So it's easier for buyers and sellers in the housing market to access those information. And those buyers and sellers would also affect the final market outcomes. So this brings concerns for the validity of the instrumental variable used in this paper. My understanding, which could be wrong, my understanding is that the instrumental variable is going to be the digitization, which is going to have an impact on the usage of algorithms or the number of algorithmic investors. That is certainly there, but I'm just concerned about the possibility that digitization could also affect other market factors which would influence the final dependent variable, let's say the prices or other market outcomes. And to illustrate my point, here is a screenshot, a figure I take from the paper. So this is the share of counties with digitized records. And on the right, I take a screenshot of Google Trend for the keyword Zillow. So we can see that about the same period, there has also been a growing interest about Zillow. So Zillow, I guess, is similar for Redfin and many other online real estate websites. So I guess with those websites, buyers and sellers in the housing market also get additional information, be it the algorithm generated estimate or just more information about available properties on market and their home characteristics. So that's my...
Sorry to interrupt. So you have like 2-3 minutes left for your discussion. So.
Okay, yeah, sure. Okay, I'll just be quick. And the next one is about like alternative explanation about reduced racial penalty. Well, I guess Lindsey did a great job explaining this part. Basically, we find reduced racial penalty not only in algorithmic investors, but also among owner occupiers and human investors. And Lindsey has 2 proposed mechanisms. I have no doubts for those mechanisms. I believe they are actually influencing the housing market in that way. It's just there are other potential alternative explanations. For example, there's one paper by Shuyi Yu, which who shows that people's reliance on Zestimate might mitigate racial disparities, and these primarily concerns, I guess, like owner occupiers or just like regular buyers and sellers. And I myself has another paper that talks about the uncertainty reduction effect of Zestimate, which could lead to same observation of reduced racial penalty. And in general, more information could just reduce statistical bias. So there could be other alternative explanations here. Okay, my last point is about the mechanism of market structure change. The paper provides a very nice theory about how everyone should specialize on their comparative advantages, and the paper shows consistent empirical results. I'm just curious about, can we say a bit more about the deeper mechanism? Like, are those human investors intentionally choosing less algorithm predicted houses, or are they driven out of the market for high predictable houses? Maybe they are lower on their speed, they cannot get the house very fast, or they have incorrect incorrect predictions about houses, or the other factors could also give those human investors a disadvantage in the competition with algorithmic investors. Okay, so that's my take on the paper. Again, it's a great topic, very nice perspective. The paper used very nice data and show interesting results. I just have some additional thoughts that hopefully could improve the paper. And thanks again for the great